All right, welcome guys. Happy Thursday. Today we're going to be going over tangent properties. I'm not feeling very well today because of my second vaccine shot. So I'm going to keep this lesson short and sweet and then get you guys some time on WebAssign. Okay? So make sure to ask questions, turn on your mic, use the chat, and we'll do that. And I'm sorry I'm low energy today. I just feel like a group of fifth graders hit me with baseball bats during the night. All right, so tangent. So what are we doing with tangent? What does it mean? Right? It's like double rainbow. Like, what does it mean? Oh man, that was my attempt at a joke. Okay. So there's a few things. There's tangent really isn't it's just the same as sine and cosine, but there's different properties. So if we take a look at a unit circle, okay, we need to remember that tangent of theta is sine of theta over cosine of theta. So personally, since I'm not using tangent a lot, I don't memorize tangent because you can always, so because you should have the first quadrant of sine and cosine memorized, right? You can always just do whatever the sine value is over the cosine value and then find tangent. So I never memorize tangent. Now, everything is online in open notes, so you can always just Google what tangent is, right? But again, like in the real world, I wouldn't memorize tangent. I would always just do this. So let's do a couple of things. So this is 0. This is pi over 2, pi, 3 pi over 2, and 2 pi. Okay. So so we're just gonna do some key points of tangent really quick. So so the key points of tangent that I just want to point out really quick is here sine is 0, right? So so 0 and then cosine is 1. So 0 divided by 1, tangent is 0 here. Okay, and then tangent is root 3 over 3, and then it's 1, right? Because you just have root 2 over 2 over root 2 over 2. It's the same thing. And then we have root 3. And then here at the top, sine is 1, but cosine is 0, and you can't divide by cosine, so that's undefined. Okay, so again, the reason why we have undefined here, right, is because you can't divide by 0. And cosine is 0 here, right? At pi over 2, cosine of pi over 2 is 0, so you can't divide, so it's undefined. And then, right, so this would be 0 again, this would be undefined again, and then, of course, right, you're gonna have symmetry. Okay, so if you just get that first one, right, you have all that symmetry going on there. Okay, and I think you guys have talked about tangent before, right? This should be review. Can you guys give me like a here? I gotta look at my okay, good. Sorry, I have my participant window over the camera window. So thank you guys for nodding your heads. So this should be review, so I don't feel too bad teaching you while I'm not feeling well. Okay, so those are the important things there. Super important that all your answers have to be from the unit circle. Must be exact. So that means no calculator. Right? And there's a couple of different reasons for that. And one is being that this way you can't cheat as easily. Okay? So all your answers must be exact. So what does that mean? It means use the unit circle. Okay? So I just really want to get going there. Okay. So that's your basic for tangent. So now let's talk about properties of tangent. Okay, so properties of tangent. So one thing that you'll notice is that, do you see how there's undefined here? So a period is, so if we go from peak to peak, see how it goes from 0 to 0? And how long does that take? It takes pi. So the period for tangent is different. So the period for tangent is just pi. And that's different because for sine and cosine, it's 2 pi. Okay, so this can trip you up a little bit. Okay, so the period for tangent is pi, not 2 pi. Okay, and then we also have to remember for the domain, and if you guys forgot what domain is what works for the input. It's all reals except, this is just a fancy symbol for reals. So it's all real numbers except x cannot equal pi over 2 plus n pi. And this just means that starting at pi over 2, any number of pi's, right? So if I add 1 pi, that gets me the 3 pi over 2. If I add 2, that gets me back here 3, 4, right? So any addition or subtraction of pi is going to be an undefined. And I'll show you what that looks like graphically in just a second, okay? So that's different about tangent, right? Sine and cosine, it's all real numbers. So domain, you have restrictions. The range for this bad boy, right? The range is from negative infinity to infinity. So nothing going on there. We're going to have vertical asymptotes. Right? Because when do vertical asymptotes happen? Vertical asymptotes happen when you divide by 0. So since cosine, right? Since cosine's on the bottom, anytime cosine equals 0, you're going to have an asymptote, right? So we can say x equals pi over 2 plus n pi. So this is just because there's infinite solutions. Okay. You're going to have x-intercepts at 0 and pi, or multiples of pi. Okay, so let's just go ahead. I don't need to write down the rest of this. Let's go ahead and graph this. So there's a couple of good things. Another things about tangent. Amplitude's not a thing here. So amplitude is not a thing for tangent. Okay, so if we're looking at our unit circle, so I'm going to graph tangent of theta here. So if we look at our unit circle, it starts at 0, and then it's increasing until it goes to undefined. So it turns out that the tangent curve looks a lot like a cubic. So if you ever forget what a tangent looks like, a cubic and a tangent look the same, though they're not the same. So it accelerates up like this, but then there is an asymptote, right, at x. Sorry, I shouldn't have done that. It's just pi over 2. And then if you look at the other one, if you go down here, right, so cosine will still be positive, right? So so cosine will still be positive, but my sine will be negative. So if you look at the ratio, you have a negative divided by a positive. It just means all of these will be negative. So then I'm going to have something like this. And then this is negative pi over 2. Okay, and that's one period of pi. Because if you go from negative pi over 2 to pi over 2, that's pi. And then it's still a periodic function. So it's a periodic function. So if we went peak to peak, so if this was at 0, then my next one would be at pi, right? Because it has a period of pi. And then it would look like the same. And then again, it's a period of pi. So I'd go pi over 2 plus pi, right? Pi over 2 plus pi. So I have to multiply this by 2 over 2. So I would get 3 pi over 2. Could have done that in my head, right? Because that's 1 pi over 2, 2 pi over 2, 3 pi over 2. And then I could do the same thing going in the other direction. Okay? So again, amplitude isn't a thing. Amplitude in tangent all it does is it tell you how it approaches infinity. So for example, if you had like 5 tangent theta, then it would approach infinity faster than tangent of theta, right? So amplitude just tells you how you approach infinity on tangent. So there's no need to worry about that. So I'm just going to do 2 examples, and then we're going to be done with class. Okay. And then, as always, if you guys need help with anything, come to my office hours. I'd love to help you out. Okay. So, and I'm so sorry I'm low energy today, guys. It's not my teaching style. It's so weird. All right, so I'm gonna have y equals tangent of x over 2. Okay. So remember, transformations work the same way regardless of what the parent function is. So in this case, right, this is my b, right? So my new period, or my noop, equals my old period over b, right? There's my formula. So this is going to be my new period equals my old period, which is pi, over 1/2. Now remember, dividing by a half is the same as multiplying by 2. So my new period is going to be 2 pi. Okay. So when I go to graph this, what's going to change, you know? I should go -2. So my period is doubling. So if I normally, and like sometimes I might draw a unit circle, I'm normally, so I start out at 0 and then I go undefined, right? So normally I'm undefined at pi over 2. Well, if my period is increasing by a factor of 2, right? I'm dilating by a factor of 2, then I just go 2 times where the old one was. So 2 times pi over 2 is just pi. So now I'm going to have an asymptote at pi. And can I just check in with you guys really quickly? Because I'm not going to lie. I can't even I don't even know what I'm saying because I'm in so much pain. Are you guys doing okay? Does this make sense what I'm doing? So how do I find my asymptotes, right? If you find your new period, it tells you the dilation factor, right? So the dilation factor, so it's 2 here. So I'm going to go 2 times pi over 2. So then I know my asymptotes are there. And then it looks like a cubic. Sorry, it looks like a cubic. Oof, that was a terrible. Whatever. Whatever. I'm not going to ask you to graph anything on our midterm or the final. Okay. But you need to know these properties. Okay. And then what are some other things that I wanted to show you? I said I was going to do 2 problems, right? And just remember, guys, you have Desmos. So I'll show that to you guys in a second, right? If you don't have a graphing calculator, Desmos has a graphing calculator. And I'll show you how to use that in a second. So let's say I have y equals -3 tangent of 2x. So this is our last example. Then I'll show you guys how to use Desmos. So again, right, my new period is going to equal my old period over my b. So that's going to be pi over 2 is my new period. The amplitude really doesn't mean anything, but the negative does. And that means it's a reflection over, it's on the outside, so that goes up and down, so I'm crossing the x-axis. Okay, so it's on the outside, so I know it's output. Output goes up and down, and if I go up and down, what am I crossing? I'm crossing the x-axis. Okay, so let's go ahead and graph this. Okay, my new period is dilated by a half. So if I take a look at this, I used to be undefined at pi over 2. So what's pi over 2 divided by 2? Well, dividing by 2 is the same as multiplying by 1/2. So it's pi over 4. Okay, I'm gonna stop there just for a second because I want you guys to make sense of it, but also because I really need to take a nap. So pi over 2 times 1/2. Do you guys see how it's a factor of 1/2, right? Dilation a factor of 1/2, so I get 4th. So when I go to graph this, this is pi over 4. This is negative pi over 4. And then the only thing is, because we're reflecting over the x-axis, right? So it used to look like this. So I'm just going to reflect that, so then it's going to look like this. Right? So the black is tangent of x, and this is negative tangent. Do you guys see how it just flipped like that? Okay. I bet you guys are like so pumped right now. You're just like, oh, I love tangent. Oh yeah, Mr. Kraft, way to instill the love of math for me. Oh my gosh, I never loved math until I had you as a teacher. You're just so inspiring. Yeah, the 3 doesn't. So that's what I was trying to say before. So here, I'll go back. Amplitude, right? So this would normally be amplitude. It just tells you how quickly you're going to infinity. And since we're just sketching, we don't really care. So again, so like this just means you're going to infinity. You're going to approach infinity 3 times faster than if it wasn't there. Does that answer your question? So like tangent is actually really easy. So the thing is what makes this section hard is that we used to go over how to graph cotangent, secant, and then cosecant. And that's what's hard. But tangent's really easy, and it just lined up really well. So that's it. We're just doing that. So I just want to show you guys really quickly how, if you don't have a graphing calculator, go Desmos graphing calculator. Okay, see how it's different than Desmos scientific calculator? So if you wanted to, you can go y equals, and then I can go -3 tangent of, what was our equation? 2x. And then there it is. And there's a bunch of options here, so I can make it bigger. I can zoom in. So for my x-axis, if I just want one period, I can go negative, and then if you guys want, you can go pi. If you just type in pi, it turns into a pi. That's pretty cool, right? And then, I'm just going to type in chat. Remember, pi is not PIE. That's what you eat. Pi is just PI. Okay, and then you can go to pi over 4. So then you just get 1. See how cool that is, guys? guys, do you see how cool that is? Now, what it doesn't show you, and I'm just going to get rid of the 4 here. What it doesn't show is it doesn't show you the asymptotes, right? And that has to do with the resolution. It has to do with the resolution of the screen. So because the resolution of the screen isn't set a current way, it doesn't show the asymptotes. Now, if you have a fancy calculator, I have a fancy calculator. I just want to show you this. So I have a really fancy calculator. I have a TI-89 titanium. I'm not saying you guys need to go buy one of these. These are really expensive. But this one will show you asymptotes. Okay. Does anybody have questions about Desmos graphing calculator or anything like that? So you guys are going to have a relatively short assignment on tangent, and that's going to be due next class. And I'm going to go ahead